So I think we are live now. Yup. So we are live. So hey guys, I'm Saion Gupta, founder at 10x for the Kids, and today, after a lot of requests, today we are gonna learn about metals and non-metals science chapter that is coming in the exam. So without any delay, let's get started. And alright, so there are no viewers right now, but we'll just rack up some viewers right now. Alright, so let's just get started. Alright, materials, metals, and non-metals. Very interesting chapter. So it's easy also if you understand it in one go. You can understand it in one go. Alright. So you are familiar with a number of materials like iron, aluminium, copper. Some materials have been given in this table. Can you name the materials? Okay, so physical properties of metals and non-metals. So this can come in a table as differences of metals and non-metals. That metals are you can differentiate on the basis of the physical properties of metals and of metals and non-metals, right? So have you ever seen a blacksmith beating up an iron piece or an article made up of iron like a spade, a shovel, an axe? Do you find a change in the shape of these articles on beating? Would you expect a similar change if you try to beat a wood log? Let us find out. So first of all, if you guys are watching, oh hi, Garf. So if you are watching, please do share this video as it will help me a lot, right? So please do share this video as it can help many other people also. So this is basically saying that when beating up, you an iron so an iron like an article like of made of iron can be drawn into sheets, but if you beat up wood, it will just kind of break. It won't draw into sheets. So this is property of metal. So we are just gonna see them right here. So take a small iron nail, a coal piece, a piece of thick aluminium wire, and a pencil lead. Beat the iron nail with a hammer, right? Try to hit it hard. Hit hard. The aluminium wire also. Then repeat the same kind of treatment on the coal piece and pencil lead. Record your observation in the table. Right. So iron nail will flatten. Coal piece will break. Aluminium wire will flatten and pencil lead will break. Lead will break. Alright. Hi Tanesh. It's nice to see you on the stream. And we will have a competition in the end. So if you answer the questions right, you may get a treat. So alright. You will get a treat. Alright. So you saw that the shape of the iron nail and the aluminium wire changed on beating. If they were beaten harder, these could be changed into sheets. You might be familiar with silver foil used for decorating sweets. You might also be familiar with aluminium foil used for wrapping food. The property of metals by which they can be beaten into thin sheets is called malleability. So you can beat up metals in thin sheets, whereas you cannot beat up non-metals into thin sheets. This property of metals is called malleability. This is a characteristic property of metals. As you must have noticed, materials like coal and pencil lead lead do not show this property. Can we call these metals? Can you hold a hot metallic pan which is without a plastic or a wooden handle and not get hurt? Perhaps not. Why? Try to list some other experiences. Okay. On the basis of these experiences, what can you say about the conduction of heat and wood and plastic? So as you know, metals are very good conductors of heat and electricity. So basically when you're heating up a pan, right, so then the heat will spread all over the pan. So it will come to the handle also of the pan. So if there's no plastic wrapping or coating on it, then it will be hot and it can cause third-degree burns also. So you must have seen an electrician using his screwdriver. What kind of handle does it have? Why? Let us find out. Alright, we have 4 concurrent viewers, right? Tanesh, hi chat, hi guys, I like the excitement in the chat, and please bring more viewers by sharing this video, right? So recall how to make an electric circuit to test whether electricity can pass through an object or not. You might have performed the activity with various objects in class 6. Now repeat the activity with the materials mentioned in table 4.3. Observe and group these materials into good conductors and poor conductors. Right. So iron rod or nail is a good conductor of electricity. Sulfur is not a good conductor as it is a non-metal. Coal piece is not a good conductor, and copper wire is a good conductor of electricity. Alright, so alright, so if you observe that iron rod, nail and copper wire are good conductors, while a rolled sulfur piece and coal piece are poor conductors. Alright, so okay, so where do you find the use of aluminium and copper wires? Have you seen wires of coal? Definitely not, because coal is a non-metal, and copper and aluminium are metals, and they can be drawn into wires, and those wires can conduct electricity. So the property of metal by which it can be drawn into wires is called ductility. So you cannot draw coal into wires, but you can draw aluminium or copper wires into aluminium or copper into wires. That is called ductility, right? All right. Have you ever noticed the difference in sound on dropping an iron sheet or plate, a metal coin, and a piece of coal on the floor? If not, you can try it now. Do you note any difference in the sound produced? Right. So, have you seen wooden bells in temples? Can you give a reason? Right. So you do not see wooden bells in temples. You cannot. So when you drop a piece of coal, you will not hear the same sound as a metal coin or an iron sheet, as iron sheets or basically metallic substances are sonorous, whereas non-metallic substances are not sonorous. Right. So try to beat up an iron. So try to beat up an iron, basically iron plate or something. So you'll be able to hear sound. But when you try to beat up a plastic plate or something, you won't be able to hear sound. Right. Or you will able to hear sound very distinct. You will be able to hear very distinct sounds, right? And guys, please, okay, so we are okay, so okay, so we'll discuss that afterwards. Integrated number, but right now, please do share the stream as it will help me a lot. Thank you. Okay, so since metals produce ringing sound, they are said to be sonorous, right? So when you try to strike a wooden bell, it won't give you a ringing type of sound. So those are not said to be sonorous, whereas metals always give you a ringing type of sound, so they are said to be sonorous, right? So after performing the above activities, we can say that some materials are hard, lustrous, malleable, ductile, sonorous, and good conductors of heat and electricity. So these are the properties of metals that you need to remember. They are hard, harder than basically non-metals. Lustrous, they give us a shine. Malleable, that they can be drawn into thin sheets. Ductile, metals can be drawn into wires. Sonorous, they produce a ringing sound, and good conductors of heat and electricity. That defines itself. Alright. So the materials which generally possesses these properties are called metals. The example of metals are iron, copper, aluminium, calcium, magnesium, etc. In contrast, materials like coal and sulfur are soft and dull in appearance. They break down into a powdery mass on tapping with a hammer. They are not sonorous and are poor conductors of heat and electricity. These materials are called nonmetals. The examples of nonmetals are sulfur, carbon, oxygen, phosphorus, etc. So please name some more non-metals and metals in the chat below, right? So please answer this question. Please give me some non-metals and metals other than mentioned in the book, right? Okay. Non-metals, nitrogen, sulfur, very good. Metals, iron is already mentioned. Non-nitrogen. Okay. Okay. So pretty good. Chemical, now these are the physical properties. These are very easy to remember, but the thing that matters the most is the chemical properties of metals and non-metals. And I'm telling again, please do share this video, please. It will help me a lot. So chemical properties of metals and non-metals, reaction with oxygen. And it was discussed that basically valency is not coming, but you should remember the valency, right? So you should remember the valency, as you don't want to like ratify the, basically what we say, you don't want to ratify whatever you are learning, right? So the formulas and all, so you need to remember the valency. You should remember the valency to clear concepts for future, plus to take out the solution of any formula yourself easily. So reaction with the oxygen, you are familiar with the phenomenon, and plus I'm telling three valencies right now that are important. So you have valency of zinc, valency of copper, and valency of iron. Iron has a valency of 3, copper has a valency of 2, and zinc has a valency of 2. Right? It's pretty cool. So reaction with oxygen. Now let's see the chemical properties. So you are familiar with the phenomenon of rusting of iron. Recall the reaction by which rust is formed. You had also performed in class 7 an activity of burning magnesium ribbon in air. You had learned that in both the processes oxide formation takes place. Complete the following reaction of iron and magnesium with oxygen. So Fe plus O2 plus H2O gives us magnesium plus oxygen. Okay, so so it is basically saying over here that we need to complete the reactions. Can anybody do this? So can you please help? Okay, please. Yes. Okay. So you don't need to learn. You should actually learn the valency, because it's really easy to remember, right? So over here we are saying iron, oxygen, water, right, gives us magnesium and oxygen, right? So I think this is the answer. All right. So we'll see the chemical formula over here below, right? So let us check the nature of rust formed as a result of the reaction between iron, oxygen, and water. Collect a spoonful of rust and dissolve it in a very little amount of water. You'll find that the rust remains suspended in water. Shake the suspension well. Test the solution with red and blue litmus paper. What do you observe? Is the solution acidic or basic? So basically, so can anybody answer that if rust solution is acidic or basic? Can anybody answer? Can anybody please answer that rust is acidic or basic in the chat? Acidic. Okay, so we tested it with red litmus paper, and I think we can see the result over here on the red litmus paper only. So you are seeing acidic, and yeah, I think it is acidic. So when a copper vessel is exposed to moisture for long, it acquires a dull green coating. The green material is a mixture of copper hydroxide, that is CuOH2, and copper carbonate, that is CuCO3. The following is the reaction. So 2Co plus H2O plus CO2 plus O2. So when we have copper plus plus moisture, then we'll get CuOH2, that is copper carbonate, copper hydroxide, and CuCO3, that is copper carbonate. Okay, so is this clear? Okay. So let's continue. Now recall the activity of burning magnesium ribbon. The ash obtained on the burning magnesium ribbon is dissolved in water and tested for its acidic or basic nature. Is the solution acidic or basic? How do you ascertain this? You must have observed that a red litmus turns blue. So oxide of magnesium is also basic in nature, right? Oxide of magnesium is basic in nature. So in general, metallic oxides are basic in nature. Let us now observe the reaction of non-metals with oxygen, right? So now let's see the reaction of non-metals with oxygen. Alright. Okay, so this is very interesting, and you need to learn this very carefully. Non-metals with oxygen, right? Right. Alright. So take a small amount of powdered sulfur in a deflagrating spoon and heat it. If deflagrating spoon is not available, you may take a metallic cap of any bottle and wrap a metallic wire around it and give it the shape shown in figure 4.4. Right? Alright, so this deflagrating spoon. As soon as sulfur starts burning, introduce the spoon into a gas jar or glass tumbler. Right? Cover the tumbler with a lid to ensure that the gas produced does not escape. Remove the spoon after some time. Add a small quantity of water into the tumbler and quickly replace the lid. Shake the tumbler well. Check the solution with red and blue litmus paper. Right? So, can you tell me what result will we get? Is it acidic or basic? Yeah, somebody can tell me that if it is acidic or basic? Alright, so we could see in the book that the solution is not turning red litmus paper blue. So that means it is acidic. Alright. So, okay, so the question is that so I told the answer. So basically, yeah, okay, I told the answer. So the name of the product formed in the reaction of sulfur and oxygen is sulfur dioxide gas. When sulfur dioxide is dissolved in water, sulfurous acid is formed. The reaction can be given as follows. Sulfur dioxide gas plus H2O gives us H2SO3. So this is a very easy way to find the finishing product. So you have SO2 and H2O. So first we will take H2, right? So we will take H2. Then we have S, and then we have O. Over here we have two O's, and over here we have one O. So O3. So it will become O3. So in the end we get H2SO3. Is this clear, everybody? I hope it's clear. Right. So guys, kindly please share this video, alright, with in your Instagram and everything, right? Insta, Facebook, everything, right? So that other people can also get help with this. So sulfurous acid turns blue litmus paper red. Generally, oxides of non-metals are acidic in nature. Recall the name of some of the laboratory acids and bases you have read in class 7. Note down. Okay. Reaction with water. So metals also react with water. Let us see how metals and non-metals react with water. Sodium metal is very reactive. It reacts vigorously with oxygen and water. A lot of heat is generated in the reaction. It is therefore stored in kerosene. So this question will come. Why is sodium stored in kerosene? As this metal is very reactive with oxygen and water, so it needs to be stored in kerosene, or it will react with oxygen and water, and a lot of heat will be generated. I hope this is clear. Alright, let's continue. Okay, so alright. Okay, let's continue. So take a 250 ml beaker or glass tumbler. Fill half of it with water. Now carefully cut a small piece of sodium metal. Dry it using filter paper and wrap it in a small piece of cotton. Put the sodium piece wrapped in cotton into the beaker. Observe carefully. When reaction stops, touch the beaker. What do you feel? Has the beaker become hot? Test the solution with red and blue litmus paper. Is the solution acidic or basic? Alright. So now let me explain this. So first take a little bit of sodium metal, dry it using filter paper. So dry it and wrap it up in a small piece of cotton. Put the sodium piece wrapped in the cotton into a beaker. Observe carefully. When reaction stops, touch the beaker, right, with water. So what do you feel? Has the beaker become hot? Test the solution with red and blue litmus paper. Is the solution acidic or basic? Okay, so can anybody tell me, is it acidic or basic? Somebody? Oh wow, two viewers just joined. Oh wow, welcome to the stream, guys. We are learning about metals and non-metals. Acidic, correct. So we'll get the sodium. Okay, so this solution will be acidic. You observe that sodium reacts vigorously with water. Some other metals do not do so. For example, iron reacts with water slowly. Generally, non-metals do not react with water, though they may be very reactive in air. Such non-metals are stored in water. For example, you can take phosphorus. It's a very reactive non-metal, as we all know. It catches fire if exposed to air. To prevent the contact of phosphorus with atmospheric oxygen, it is stored in water. So pretty cool, right? So we have 3 viewers now. All right, 1 viewer. All right, guys, please join the stream, please. All right. Reaction with acids. So let us see how metals and non-metals behave with acids. So let's do this activity first, right? This activity is important. Take samples of metals and non-metals listed in table 4.5 in separate test tubes and label them as A, B, C, D, E, F. With the help of a dropper, add 5 milliliter of dilute hydrochloric acid to each test tube one by one. Observe the reactions carefully. If no reaction occurs in the cold solution, warm the test tube gently. Bring a burning matchstick near the mouth of each test tube. Repeat the same activity using dilute sulfuric acid instead of dilute hydrochloric acid. Record your observations in this 4.5. Okay, so this is a fun activity. You can do this yourself. So, is there a difference in the way metals and non-metals react with acids? What could the pop sound in some cases be due to when burning matchstick is brought near the mouth of the test tube? Alright. So you must have found that non-metals generally do not react with acids, but metals react with acids and produce hydrogen gas. So the pop sound, that burning pop sound, represent that there's hydrogen gas produced. You must have noticed that copper does not react with dilute hydrochloric acid even on heating, but it reacts with sulfuric acid. Alright. And now finally we have reaction with bases, and this is also very important. Reaction with acids was important. Alright. So after this we'll have displacement reactions, and displacement reactions will definitely come in the paper, as they will come in the paper, right? As they are mentioned in the book, as our teachers say. So prepare a fresh solution of sodium hydroxide in a test tube by dissolving 3-4 pellets of it in 5 milliliter of water. Drop a piece of aluminium foil into it. Bring a burning matchstick near the mouth of the test tube. Observe carefully. What does the pop sound indicate? As before, the pop sound indicates the presence of hydrogen gas. And guys, you will get an award if you answer the last question in the stream that I'll ask, the special question that I call. Then you will get an award, or you can say a treat. So stay in the stream. Metals react with sodium hydroxide to produce hydrogen gas, right? Reactions of non-metals with bases are complex, very complex. Displacement reactions. So anybody, before I continue, does anybody have an idea of what displacement reactions are? Does anybody have the idea of that? Alright. Does anybody know that what displacement reactions are? Tanish, you can answer. Tanish, would you like to answer?
No.
Alright, so let's continue. So basically, displacement reactions are when one metal displaces the other metal. So in there we displace the that definition was not clear. In displacement reactions, we displace the reactions. Alright, so that's not clear at all. So in displacement reactions, uh, a more reactive metal displaces the less reactive metal. Basically, we have zinc. What solution? I don't remember. Zinc. Yes, so we have copper sulfate solution and we add zinc to it. So obviously, zinc will displace copper and copper will get in solid form, and zinc, then we'll get zinc sulfate solution plus copper. Alright, so we'll do this right now. Displacement reactions. Recall the activity of the reaction between copper sulfate and iron that you performed in class 7. Let us observe some more reactions of that kind. Take 500 ml beakers and label them A, B, C, D, E. Take about 50 ml of water in each beaker. Dissolve in each beaker a teaspoonful of each substance as indicated in figure 4.6. Keep the beakers undisturbed for some time. Record your observations in your notebook. So in beaker A we have copper sulfate plus zinc granule, that is zinc. So we'll get zinc sulfate. Then we have copper sulfate plus iron air, so we'll get FeSO4 because I believe that iron is more reactive. Yep. Zinc sulfate plus copper, so we'll get no reaction as. So this is very important, guys. If you leave the stream at this point, it would be very harmful for you as I'm explaining what is happening. So zinc sulfate plus copper. Now this will have no reaction as zinc is more reactive than copper, and we'll get zinc sulfate solution with copper. Iron sulfate with copper, still no reaction as iron I believe is more reactive than copper. And zinc sulfate plus iron nail, so we'll get FeSO4 plus zinc, right? And you have to mention in the paper that whatever you get is in aqua form, or in solid form, or in gaseous form, right? So you have to mention this in the paper. It's very important. So what changes do you observe in the various beakers? You have read that one metal displaces another metal from its compound in aqueous solution. In beaker A, zinc replaces copper from copper sulfate solution. That is why the blue color of copper sulfate disappears and a powdery red mass of copper is deposited at the bottom of the beaker. The reaction can be represented as follows. CuSO4 plus zinc gives us zinc sulfate plus copper. And to remain safe, you should mention that what's the color of something and if something is colorless or not. I'll just have water in a second. Right? All right. Thank you for coping up with me. All right. Okay, so similarly, you can write down the reaction in beaker B also. Please tell me that can we store lemon pickle in an aluminium utensil? So no, basically you cannot store lemon pickle in an aluminium utensil, as lemon pickle is basically acidic, and acid reacts with metals. So aluminium will react with the acid, and basically the food will basically the pickle will get spoiled basically. So you should not. All right. I understood the reactions taking place in beakers A and B. I'm still confused why there is no change in beakers C, D, and E. So that is because the metals. So basically in C, D, and E, zinc is more reactive than copper. So no change will take place. iron is more reactive with copper, so no change will take place. Displacement is basically displacement of one. So basically, it is displacement of one metal with the other. That is the more reactive metal. So a more reactive metal will displace the less reactive metal. So right now, copper is less reactive, so that way it won't be able to displace zinc or Fe. And Fe is okay. So what's it saying? So there's no change in C, D, and E. Alright, so zinc is more reactive than iron, so that's why no change will take place. I thought that iron is more reactive, but zinc is more reactive. Alright guys, so let's continue. So there could have been displacement of zinc by copper in beaker C and by iron in beaker E. Similarly, iron could not be displaced by copper in beaker D, right? Since we do not see any change in beaker C, we can infer that copper is not able to replace zinc from zinc sulfate. But why? When zinc can replace copper in beaker A, why cannot copper replace zinc in beaker C? Remember that science is not arbitrary. It follows definite rules based on facts. And the rule here is that zinc is more reactive than copper and iron. A more reactive metal can replace a less reactive metal, but a less reactive one cannot replace a more reactive metal. Now you can understand why there are no displacement reactions in beaker D and E also. Can you guess the sequence of metals from more reactive to less reactive among zinc, iron, and copper? So valencies are not coming, but reactivity series is coming, right? So you need to know the reactivity series. It should be there in your brain, fixed. Alright. So uses of metals and non-metals, and then we'll move on to the special question, right? That you all have been waiting for, I believe, right? And through which you will get your prize. Alright. Uses of metals and non-metals. So you should be able to guess why metals are used in making machinery. Automobiles, aeroplanes, trains, satellites, industrial gadgets, cooking utensils, water boilers, etc. You are also familiar with the uses of some non-metals. Here are some interesting ones. We are sure that you will guess them right. Non-metal is essential for our life, which all living beings inhale during breathing. Oxygen. Non-metals used in fertilizers to enhance the growth of plants. Potassium, I think. Yup, Alright, I don't know. I confused in this one. Can anybody help me? Alright. Non-metals used in water purification process. Chlorine. I believe it is chlorine already. Non-metal used in purple colored solution which is applied on wounds. That is as an antiseptic. Iodine, and iodine uses what? I don't remember. Non-metals used in crackers. Can anybody tell which non-metal is used in crackers? Like crackers. I believe it's phosphorus. I don't know. So I heard that magnesium is found in plants. In what form is it found in them? Okay. So can anybody tell? Okay. So magnesium is found in plants. In what form is it found in them? Can anybody tell? Then we'll do the case study. In what form is magnesium found in plants? Anybody can tell, right? Somebody can in the chat. I believe no one wants to answer, so let's move on to the next question. The doctor reported iron deficiency in my body. Where is iron in my body? Okay, so he's talking about another iron, right? That iron that is in metal form is different from the iron that we have in our body, right? So not to confuse that with the body iron, right? Okay, so this is the case study, I believe. So in class 7, you have learned that in chemical reactions, new substances are formed. These substances are different from those which underwent the reaction. Now, if a substance cannot be broken down further by chemical reactions, by cooling, heating, or by electrolysis, it is called an element. Sulfur is an element. So is iron. Carbon too is an element. The smallest unit of an element is an atom. A sample of an element contains only one kind of atom. The atom of an element remains unaffected by physical changes in the element. For example, an atom of liquid sulfur would be exactly the same as the atom of solid or vapor sulfur. So this is your case study, guys. This will come in the paper, right? So although we have an infinite variety of substances in the universe, the number of elements forming these substances is limited. There are no more than 94 naturally occurring elements. An important classification of elements is in terms of metals and non-metals. Most of the elements are metals. Less than 20 are non-metals. A few are metalloids, which possesses characters of both metals and non-metals. Okay, so we'll learn about metalloids in the next class. But now to the question that you all have been waiting for. Very the question that you need to solve in 10 seconds, right? You get 10 seconds, and by the clock you will get 10 seconds this time. So stopwatch. Alright, I'll start 10 seconds after I tell you the question. So what will you get? Okay, so is this valency? Okay, this is valency related. I'm not asked. Okay, I'll ask you a valency related question to see how much focus you were in the class. So open up your valencies, that's it, and I'll give you 10 seconds. So PB plus PB. Okay, I'll write PB plus, and no googling, alright? PO and 4. That is down basically. And no. Okay, I'm starting the timer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now it is reaching to you in the stream. Alright, I can see. Alright, nobody could answer this in 10 seconds. Shocking. But okay, I give you credit for that. It was because there was valency in it. Alright. So this is a winning question now over here, I think. I'll write it in the chat. Oh, you can see it. Okay. So I'll tell the question in 3, 2, 1, go. And I'll start the timer. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Alright. So now it's coming to you in the stream. Let's go. Okay, somebody needs to win this treat or something. Alright, nobody. Alright, so I guess we don't have a winner this time, right? So there's only one viewer left. So you can just tell me in the chat, do you want to do the exercise or you have any questions? So now we have a question session now for 2 minutes. If you have any questions, you can ask. Alright, so if you have any questions, I'm willing to answer. Alright, so I guess there are no more questions, and I hope you guys liked the video. If you did, please don't forget to smash the like button so that it can reach out to more people. And thank you guys. Stay safe and keep watching my videos.